Good morning, fifth graders. Today we are on page 236 of your student journal, and we're in Unit 11, Lesson 8. So we are going to be moving on to something a little bit different. We've been focusing on the standard measurement system and the metric measurement system, and now we're moving on to something called line plots. Okay, so our objective or the goal today is I will solve multi-step problems involving line plots. Okay, so that is our goal today. Now, let's look at our vocabulary since this is a new topic for us. And we see the definition for what a line plot is. It says, displays a set of data on a number line. Each X represents one piece of data. So what you'll notice is there's usually a title to these line plots. So this is talking about Jenny's exercise. And then this is the data beneath. These are the numbers that will be in the data. So actually all these numbers aren't truly represented in the data, but some of them are. So there's a scale to it. So notice we have 2/4, 3/4, 4/4, and then they included 5/4 even though there was no data there because we want to keep our numbers in scale. But the actual X's represent the pieces of data. So that this tells me, if I count them, there's 1, 2, 3, 4, 5, 6, 7 X's, which means that there's 7 pieces of data in this set. And there's 1 2/4 because there's 1 X. There's 1, 2, 3 3/4 because the 3 X's let me know that. There's 1 4/4. There's no 5/4. There's 2 6/4. And there's no 7/4. So these are the actual numbers or the actual pieces of data that this represents. Okay, so let's look at our steps because we're going to follow these pretty closely for the next few lessons. It says read the word problem and identify the key information. Find common denominators if necessary. It is going to be necessary. The only time it's not going to be necessary is if they gave them to you with common denominators. Okay, order fractions from least to greatest on a line plot. This one I tend to do a little bit different when I solve these. I usually just like to circle the least and greatest. The reason I circle the least and the greatest is it tells me when I make my number line, what needs to be my smallest number and what needs to be my largest number. So, and then I kind of order them as I put them there, but this is how I attack step 3. Step 4 says make a mark, and when they mean mark, it's an X for each number in the data set on the line plot, and then solve using multiplication. A lot of times we solve using addition as well. It kind of depends on the question and what works best for each question. Okay, so I'm going to get started and show you what this looks like. Here is my first problem. My first problem says, Lydia wants to exercise a total of 10 hours this week. Based on the line plot that shows the hours worked out at each station of a workout circuit, did she meet her goal? Okay, read the problem and identify the key information. Okay, well what I notice first when I look at this is my first step says to read it and understand it. I do understand it, that she wants 10 hours a week and this is what she worked out, so I need to see if she actually accomplished her goal. Then it says to find common denominators. Well, for this problem, when I look at my denominators, they're already common, so I can skip that. Step 3 says that I'm going to order the fractions from least to greatest, or just look at the least and look at the greatest. So when I look here, I see 1/2 is my least, and I see 3.5 is my greatest. And it looks like my scale is going to be counting by halves. So I'm going to get my number line ready. say a half, 1, 1 1/2, 2, 2 1/2, 3, and 3 1/2. I didn't really leave a lot of room for my title up there, so maybe I'd have to put a title down here. I could just say like maybe Lydia's exercise. Okay, and you didn't see that. All right, so now what I'm going to do is it says make a mark for each number. Okay, I like to cross them off as I go so I don't make a mistake. So I have a 1. I have another 1. I have a 2 1/2. I have a half. I have a half. I have a 3 1/2 and another 1. Another thing you can do to make sure you didn't make a mistake is you could count them after, just to make sure you have all of them. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so now my number line or my line plot's made. Now I'm going to use multiplication or addition to solve this. So the way that this kind of works well is I can look at these together and say 1/2 plus 1/2 would equal 1. 1, 1, 1, so 3 1s is 3. 1, 2 1/2. 1, 3 1/2. If I add these together, what do I get? Well, my 2 halves equals 1, so I could do that. I could cross those off and add another 1 there. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 exactly. So my answer would be, yes, she met her goal. She just made her goal with exactly 10 hours. Okay, so let's see another one. The next one's a little bit more complicated, which is why I did that one second. Okay, here is this problem. It says, Renee had a packet of pipe cleaners cut at different lengths for an art project. The data below shows the different lengths of the pipe cleaners in inches. How many inches of pipe cleaners does she have? Okay, so these all represent maybe like little cuts of a pipe cleaner, and if you know what a pipe cleaner is, it's that wire with the little fuzz on it. We use them for crafts sometimes. Okay, so my second step says I'm going to look for common denominators. I definitely need to do that for this problem because when I look, I see different denominators. Luckily, they're all 4s and 8s, which makes that not too tricky. So it looks like 8 is going to be my least common denominator. So I need to change some of these. So 5 1/4 is the same as 5 2/8. 5 6/8 I could leave alone. 5 2/8 is the same as, 5 2/4 is the same as 5 4/8. 5 1/4 we already did over here. We said it's 5 2/8. I could leave that, I could leave that, I could leave that. 5 2/4 is the same as 5 4/8. 5 1/4 is the same as 5 2/8, and I could leave that one. So I did have to rewrite quite a few of them. Okay, so now that they all have common denominators, I am ready to make my line plot. And before I do that, remember I'm going to circle my largest and I'm going to circle my smallest so I know where I need to start. So it looks to me like my largest, well, they're all 5s. Ladies and gentlemen, I'm going to shut my windows. All right, thanks for being so patient. Okay, so it looks to me like my largest and my smallest, I see a 5 2/8. It doesn't seem like I see anything smaller than that. And then I see a 5 6/8. So it looks like that's going to be my largest and smallest. So now when I make my line plot, I know that I'm going to start with that. 5 2/8, 5 3/8, 5 4/8, 5 5/8, and 5 6/8. Okay, ready? So now we're going to add our x's and cross off as we go. Ready? 5 and 2/8, there's 1. 5 and 6/8, there's 1. 5 and 4/8, 5 and 2/8, 5 and 6/8, 5 and 5/8, 5 and 4/8, 5 and 4/8, 5 and 2/8, and 5 and 5/8. Okay, and I could double check again and count. I have 3, 6, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I don't think I missed any. So now what I can do is, now that I've made the marks, I'm ready to solve using multiplication and addition. So I'm going to move up here to look at this. So if I had 5 and 2/8 and I have 3 of them, what does that actually equal? Well, let's think about it. That means you have 5 and 2/8 plus 5 and 2/8 plus 5 and 2/8. So really you have 15, and when I add fractions, I only add the numerators. So 15 and 6/8. I could probably have done that without having to do this part. So for here, how many would I have? Well, if I had 4, I have 3, so I have 4/8 3 times. So 4/8 plus 4/8 plus 4/8 would be 12/8. And then I have 1, 2, 3 5s, which would be 15. Okay, down here I have 2 5/8, so 2 5/8 is 10/8, and 2 5s is 10. Over here I have 2 6/8, which means that's 12/8, and 2 5s, which is 10. Okay, so notice these are improper fractions. I'm not going to simplify them yet, but now I can. So what is my fraction? Well, I have 6 plus 12 is 18, 28, 38. I have 48/8. Let me double check that. 6 plus 12 is 18, 28, 30. Nope, that was 40. That's why I double checked that. I'll do it one more time. 6 plus 8 is 18, plus 10 is 28, plus 12 is 48, and then I have 15 plus 15 is 30, 40, 50. So now that I have 50 and 48, I need to now fix this. Well, there's a couple of strategies you could use. I always use this strategy called in and out. So 8 can go into 40 how many times? 5, which tells me that 48 is the same as 5, which gives me my answer of 55 inches. Okay, I do know that these are quite a lot of work, ladies and gentlemen, but I also know you're able to handle them. Okay, so let's jump in and do some together now. We're going to be on page 237. Let me grab my book, 237. And here is our first problem. And it says, Mrs. Roderick gave each of her 9 students a cup of lemonade with different quantities in each of them. If she serves the same quantity one more time to each child, how much lemonade would she have made in all? Okay, so we have to first understand the problem. So these are her 9 students, and this is how much lemonade she gave them. It is a little tricky because it says she serves the same quantity one more time. I might save that part for the end. Okay, so I'm going to jump right in. I don't need to find common denominators because they all have the same denominator. So I'm going to find my smallest, which looks like it's 5/8, and my largest looks like it's 1. Okay, so let's set up our scale is going to be by 8s, 5/8, 6/8, 7/8, and 8/8, which is equal to 1. So I have 1, 2, a 7/8, a 5/8, a 7/8, a 6/8, a 6/8, a 6/8, and a 7/8. Okay, and it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9 to represent her 9 children. Okay, so now we have to kind of add these and see what we get. So I know they don't leave me a lot of room because I write big, but I have 1 5/8 plus, well, I have 1, 2, 3, 4 6/8. So 4 6s would be 24/8 plus 1, 2, 3 7s, which would be 21/8 plus 1/8. So what is our numerator here? 5 plus 24 would be 29. 29 plus 21 is 29 plus 21, I'm sorry, 29 plus 21 is 50. And 50 plus 8 is 58/8. That's what I'm coming up with, 58/8. Now remember though that she did, I'm going to come back to this question now, or part of the question now, where it says she gave this amount to every child again. So I'm actually going to double 58/8 and say she did it twice, which means I get 116/8. Well, if we get 116/8, that looks like it's my final answer, but then we're going to need to now correct that because that's a very, very improper fraction. I'm going to use my same strategy, that in and out strategy, to correct it, or to not correct it, but write it in the correct form or in the best form possible. So let's do that. So this is going to be in and out. They really did not leave us a lot of room, so I might have to move up here and say 8 can go into 116 how many times? And so 8 cannot go into 1. 8 cannot, it can go into 11 though. 8 can go into 11 one time. 1 times 8 is 8, which gives me 3 left. So and then when I bring down, I get 36 when I bring that down. So now, let's see, we get 8 can go into 36 4 times, and 4 times 8 is 32, and when I subtract I get 4. So I'm going to bring that up. So it's 14 and 4/8, and I'm not sure if this is how your teacher taught you to correct improper fractions, but 14 and 4/8 would be our answer of how many cups. We could also write that as 14 and a half cups, but that's how much lemonade she served. So 14 and 4/8 or 14 and a half. So again, we've been seeing these problems that take a lot of effort. Okay, let's move into our last problem together. And our last problem together says, Max measures 7 sticks he found on a hike. 3 sticks measure 2.5 inches. 2 sticks measure 1 1/4 inches. 2 sticks measure 2 inches. If he needs 42 inches of sticks to make a model log cabin, how many of these same sets of sticks should he find? Okay, well, let's see. He has 3 sticks that measure 2.5. When I come down here, I don't see a 2.5, but I know that 2.5 is the same as 2 1/4. So he has 3 of those. He also has 2 sticks that measure 1 1/4. And he also has 2 sticks that measure 2 inches. Okay, so let's see what he has. Well, if we add them, and I might do it up here because there's not a lot of room, 2 1 1/4 would be 2 1/4 would be 2/4, and 2 1s would be 2, plus 2 2s is 4, plus 3 2/4 would be 6/4, and 3 2s would be 6. So what do we have there? Well, we have 2/4 plus 6/4 is 8/4. And 2 plus 4 is 6, plus 6 is 12. Okay, well 8/4, I could use my in and out strategy, but I actually know 8/4 is going to be 2 because I know 4/4 is 1 and 4/4 is another 1. So that equals 14, which tells us then that our sticks together equal 14 for one set. One set equals 14. He needs 42 inches though. So if he has 2 sets, he'll have 28. If he has 3 sets, he will then get his 42. So he's going to need 3 sets to get 42. Okay, boys and girls, I appreciate you sticking through that long video, especially when my gardeners are outside. I hope you have a fabulous day. Bye-bye.